Hey everyone, good evening, good morning, happy noon, I don't know, wherever you sit. Welcome to our next Azure Rosenheim meetup. So today we will do the second part of our chaos engineering with Azure Chaos Studio talk by my colleague Phil. So just some words on our side. So my name is Nico Meisenzahl. I'm leading our DevOps team. I'm a cloud solution architect, GitLab Pure, Microsoft MVP. And with me on our today's speaker is Phil, but over to you.
Yeah, hi everyone. I'm Philip Welz, Senior Kubernetes DevOps Engineer at White Duck. I'm also Azure MVP GitLab Hero, and my daily business is around everything with Azure, Kubernetes, Terraform. You can choose.
Okay, so some housekeeping tasks. So today we are in the Zoom meeting here. So if you would like to ask any questions to interact with us, so feel free to join the Zoom meeting. You will find the link to this meeting on our Meetup page. Otherwise, you can also, of course, join via YouTube. So this meetup is streamed on YouTube. So also feel free to ask comments there. We will monitor both places, Zoom as well as YouTube. Another housekeeping thing, in case you missed the first part of this series, you can find the recording on YouTube as well. But Phil will also do a short sum up of the first part starting basically now. So over to you, Phil.
Yeah. So what we will do is, the agenda is not up to date. Oh my God. Okay, and what we do is, like, every time we will take a look at some Azure news. We will do a short recap or a short introduction of chaos engineering. We will skip the key principles. We will also do a short recap of the Azure Chaos Studio so that everyone is on the same page. Then we will demo. So this time we will do more code stuff with Bicep and Azure Chaos Studio. And after demo, we have some time for questions, networking stuff, and yeah, to talk a little bit. Okay, Azure news. So we have a lot this time. First, and is that Mount Azure files and distributed storage is now GA with Azure Container Apps. So you can finally add stateful storage for the container apps. What we also have is larger SKU for app service environments. It's a new SKU v3. So it has up to, I think, 265 gigabyte you can choose now. And yeah, this is coming now. We also have Azure Monitor Alert now support duplicating alert routes. So we can duplicate the alert routes with duplicate command now, and we can set them up and duplicate them. We have also a long-awaited feature is the private link support for inbound traffic on the RP management. So finally, we have to not use the RP API management in public, so we can also use the private endpoint or private link for inbound traffic to keep it in our VNet. And last but not least, this was a huge thingy that we finally cannot or should not or must not use any more PATs when we work with Azure DevOps. So we have now service principal or managed identity support for Azure DevOps. This was a huge thing. Then, as you may know, last week, or was it last week? I think last week was KubeCon. So Nico and me were there. There was a whole day for Kubernetes on Azure, and there were a lot of announcements. And we can also talk these things through. So the Azure CNI overlay becomes GA. The Azure CNI overlay tackles the thing that when you created the Kubernetes cluster with the Azure CNI, all of your IPs in the subnet were pre-allocated by the nodes and the max pod setting. So basically, spawning new nodes to the cluster when we have a large setup could be an issue. So with the new Azure CNI overlay, the pre-allocation is a gun, let's say, and it's more easy now to plan your environments. Oh, sorry. Then we have the Azure Active Directory workload identity with AKS turned to GA. So everybody maybe know pod identity. So this is now deprecated, and workload identity is the new way to use identity for resources on Azure on AKS. We will also take a look later. So it's in my demo included. We have now Kubernetes 126 support in AKS. It's also going GA. So Azure is really, I think the upstream is on 127 and Azure is just a few months behind. So they're really focusing on short being up to date with the upstream. Also in the same, let's say, box, or in the same box is the announcement for the AKS long-term support version. So basically what the AKS team or the Azure team announced is that there will be a long-term support for the Kubernetes version, which is about to be supported 2 years. And what they do, they will fork upstream Kubernetes to a long-term support version, and also will maintain it by their own. They hope that all other big vendors like Amazon or Google will hop into this train. We have to see. I can check it out how it will go. There's our own GitHub repo for this, and yeah. Can everybody maybe mute themselves who's on Zoom? This would be nice. Or can Anila mute? Can I mute? 1 second. I try to mute. No, I cannot mute. Okay, yeah, it's gone. Also announced during KubeCon open cost for AKS cost visibility. So Microsoft joined the open cost initiative. So they contribute to open cost, and what's the outcome is that you have a cost provider for Azure resources like compute, VMs, that you can now, in a multi-tenant scenario, for example, you can now really
so maybe Anila, can you mute the other people's, please? Because you're the owner of the meeting.
So what's the outcome? So back to when we're in a multi-tenant cluster, we can now basically for this we have a VM scale set, and we have 10 VMs, and everybody was split built, and now we can really just make the bill on consumed resources by Azure or by the team, and make it the billing teams. Oops! Oh my God, what's going on here? Oh, my mouse. I'm sorry. Yeah. Okay. Then, as we talked with the AKS product owners, they have a real lot of scenarios where users or customers modify things in the so-called node resource group. And what they did there is to make the NRG lockdown as public preview. So basically, when you spawn an AKS, the AKS control plane spawns a new resource group. And this is for everything which is tied to the cluster lifecycle, like the VMs, the load balancer. And sometimes customers, like I said, modify the stuff, and which lead to unstable environments. And I think this will be also the default, but at the moment it's public preview, so nobody can modify things there. And the next huge announcement, from my point of view, is public preview of the AKS service mesh add-on for Istio. So everybody know Istio. Istio is a service mesh, or let's call it the father of service mesh, but it's a beast and hard to manage and maintain. So what you get now is a fully managed Istio from Azure, also support, and you just have to use it. So everything will be done by Microsoft. Okay, so far so good. Then let's jump over. Or are there questions? Then maybe it's a good time. Okay.
So let me check on YouTube. We don't have any so far. So, yeah. But if you have any questions, feel free to post them.
Yeah. Then let's make a quick recap of chaos engineering.
Still, you're on mute. Sorry.
Thank you. Okay, sorry. So I will start again. So the first, or the history of chaos engineering, the first iterations were introduced by Amazon or Google. So Amazon created game days where the reliability of applications were tested. Also, Google introduced some disaster and recovery testing days where they destroyed application and restored them. And Netflix there then made it more famous with their Chaos Monkey tool, and later with the Siemens Army software suite, where you had a lot of tools built into the chaos engineering. Yeah, also Martin Fowler, I think in the dev space, he's really well known. He had this the thing about the Phoenix servers, that Phoenix, the servers are like the Phoenix, it should rise from the ashes and then be gone. And then finally, 2014, we had the first job roles called Chaos Engineer, again by Netflix. Today, it's in all cloud vendors, a part of the well-architected framework for AWS Azure. For Google, I'm not sure. I did not found it, but maybe I looked wrong. We have own chaos engineering conferences. We have the Chaos Conf, Chaos Carnival, Conf 42, and so on. And we have CNCF adoption. I think Chaos Mesh, which we also take a look later in the demo, is incubating project. And we have also Litmus Chaos, which is also incubating CNCF project. So not far from graduating. And yeah, to break down chaos engineering, we have this one sentence from the Principles of Chaos org. Chaos engineering is the discipline of experimenting on a system in order to build the confidence in the system's capability to withstand turbulent conditions in production. And then why is it production capital? Because every environment will differ from the usage patterns, from the traffic which is on the environment. So you only have in production the real usage, the real network traffic, and the real outcome of what you want to achieve with this testing. And the practice of chaos engineering is like a small circle. We build a hypothesize what will happen or what we think our application will handle, our fault which we inject. For example, we can inject a kill pod scenario where we kill a pod, and what we will think will happen is that Kubernetes takes care and spawns a new pod because the pod is killed, for example. Then we will run the experiment. We will analyze the outcome. So what happened, how everything is reacted, how our, so with monitoring and observability for sure, and how we can improve this, that we have no more outage again, for example, or not this. And a proof could be we always will run 2 replicas of the pod. This could be an outcome of so yeah. Okay, that's it for the chaos engineering part. Let's go back to the Azure Chaos Studio. Yeah, it's a managed offering from Microsoft. Has a deep ARM integration. Like I said, it's a pillar of the Azure well-architected framework. It's at the moment public preview. It was announced that it will be changed in April, but they moved the date, I think, to 2024, as I checked today. So they will. So we have 8 more months to use it for free, and then let's see. What it does is it orchestrates fault injection into Azure resources, and you have also the private options. You can use the VNet injection. And what we have fault, we have types of faults, we have service direct faults. So they run directly on Azure and don't require anything to be installed. For example, in Azure Key Vault, we can run faults directly against, so we don't need to install the agent. If we take a look at the VM, we need to install the agent from Azure Chaos Studio, so it's an agent-based fault. Then we have providers, we will take a look later, and libraries. The resources, we have the targets, as I mentioned. So targets, this enables really a resource to interact with Chaos Studio. So you in the target section in the portal, you will not see all Azure resources. You will only see those ones which are can be used with Azure Chaos Studio. And we have the capabilities. This is a child resource of a target. And this enables really a particular fault for the resource. So this is a bit tricky at the moment because this is not possible with code. So you have to really use the UI here. But this is a limitation of Bicep at the moment, or the ARM API. Hopefully this will change soon. I think in Bicep, the next release, which is scheduled 1st of May, this is likely to change. And we have the experiment, which describes the faults to run and the resources to run against. And here a little bit an overview. How does it look? This is a chaos experiment. we have steps and we have branches. So steps run one after another, and branches, they run at the same time. And at the bottom of this experiment, we have the selector, which Azure resource is should the experiment run against. We have 3 layers of security with Chaos Studio. So we have the Azure AD. So we have RBAC roles to grant access to Azure Chaos Studio. We have every experiment creates a system managed identity, and we need to assign this system managed identity to the Azure resource we want to run the fault against. I will show it also later. And we have this resource onboarding, which we called before capabilities. So, oops, God, what's going on here? Here. Resource onboarding, so where you really have to enable this capability for this target. So this is also a layer of security to not run, just create the experiment and run it against all the VMs in Azure. So you really have to onboard this. And the agents, they use a difference. So for agents, we use a user-assigned identity. That's the security layer. Okay, then we have the chaos mesh. So I will show the providers and the thing when I switch to the demo, because now I have to talk about more. Okay, the providers are built in the resources with which targets Azure can communicate. And for the AKS, or for Kubernetes Cluster of Azure, we have to use the chaos mesh in a particular way to communicate with it and inject experiments here. And what is Chaos Mesh? It's an open source project. As I mentioned before, it's CNCF incubating. It's completely built on CRD, so it will install CRD, so custom resource definitions. So you have you could inject own YAML files. It has 3 main components. It's a dashboard where you can schedule your experiments and so on. What you can do in dashboard: create experiments, create faults, select targets. We have the Chaos Controller Manager, which is responsible to control the injection of experiments. And we have the Chaos Daemon, which runs as a daemon set, which basically communicates with the pods. So the Chaos dashboard, we will not take a look today because we are focusing on the Azure Chaos Studio part. So we just use the Azure Chaos Studio for now. And now we can start also with the demo part. Okay. One more second. I have to. Okay. Okay, let's share. I will just share my screen here. Google Chrome. Okay, hope for everybody can see it. Yeah. Okay, for example, here we have the Chaos Studio documentation, and here's the so-called fault providers, where we can see what is going on. And when we find network security group, manage clusters, and then as you can see a target name, it's called Chaos Mesh. And what we can also see is which role or which suggested role, it's not you have to use this role, but this role needs to be assigned to the Chaos experiment identity in order that the experiments can work. And here's also the fault library. At the moment, we have, I don't know how many, I would say 34, 35 experiments. And then you can see here, when you scroll down, we have the one which we will want to use today. For example, the pod fault here. It's the AKS Chaos Mesh pod fault. And then you see the code which we need to inject in the experiment to inject our so-called experiment there. Okay. Any questions so far?
So none on YouTube. And also in Zoom, if you have any questions, feel free to just unmute it or type them in the chat.
Yes. Okay, then I will share my VS Code and hope that you will tell me if it's big enough. This is the one. So every code is available on GitHub. So we do like an introduction. So it's not that much complicated. So basically what we do, we have some bicep modules. I will just run through, and if some questions will pop up, then you're glad to raise them. So basically what we do, we will run a bicep on subscription level. So we will create a resource group, which we want to use later. So at the moment, this is RG RKS Chaos demo, I think. Then we will create the AKS. We will create the identity for the AKS. We will use a module to create a Kubernetes cluster. And yeah, we will assign the managed identity to network contributor role, because this is needed to spawn more nodes later. We will use the Azure built-in GitOps function. So it's an RKS extension, which can be inside on the AKS. So, and then we will point it to this GitHub repo, which is from myself. And like I said, it's public. We will point it to this configuration here. We will create an Azure Key Vault. And we will use, in this scenario, so let's start with this one. We will use a workload identity. So what we basically have is, I have a namespace called archive demo. Is it readable, or should I make it bigger? I'll make it bigger.
No, I think it's fine.
Okay. What we basically have is a workload identity demo pod, and what it's doing, it just connects to the keyword with the workload identity and asks for the secret, and the feedback is hello, I'm a secret. We will also see it here. I created it in a module. Let's see in a module. We create the key vault and we created the secret, and the value of the secret is hello, I'm a secret. And what we want to do now is inject access denied, or we will close down the key vault so that the pod cannot access the application anymore, the key vault anymore, and does not get a secret. So because this is a common scenario where application has a secret, for example, in our case, we use the CSI provider more, but now with the workload identity, we can also check this. And we can also take a look how the workload identity is set up. Basically, it's a webhook, and you just need to give your tenant ID to the workload identity webhook Helm chart. And I think you need a cert manager for the workload identity to work. That's the part here. And then you need to know in advance for sure how your namespace will be and how your service account in Kubernetes will work. Because what we do here is we will create an OITC issuer on the AKV cluster, AKS cluster, sorry. So the AKS cluster is a trusted resource to the managed identity. And then we will call the subject. The subject is, you can see it here. Give me 1 second. Yeah, the subject is a system, a service account, AKV demo. It's the namespace and the name of the service account. So this one we have to know in advance. And then we can create a federation between this service account. So the pod mounts the service account and connects to the Azure Active Directory and authenticates himself as the service account. And as we use this federated credential federation with the issuer from the Kubernetes cluster and the subject, which is this, the authentication request will run through the Active Directory, and our pod or our service account or our code is able to get the secret content. And what we just want to do now, we can switch also. So I did not run the test before. I just created this with the code. So we go to the Azure Chaos Studio again. Yeah, it's a bit tricky here. Switch between. Basically, on the target page, what we have to do, because it's not available with code today, we have to go on the key vault, and we have to enable this particular fault. I enabled it before, which we will run. So this is the third layer of security. So when I remove this tickle here, the experiment will fail. So we have to really enable this here. And we can just go and experiment, and we have here AK4 access denied for 5 minutes, and I just can go here and hope everything will work now. And then I'm happy. So this one asks every 1 minute to get the secret. And what we can also check now here, what this will do basically. I think we had the demo last time, but we did it more on fast way. We have this demo and we have the network settings. Basically, at the moment, it's a public keyboard, and this fault will just disable the access here. It's not a real chaos mesh demo, but it's a as workload identity. I thought let's check this and take a look at the workload identity, how this will work with chaos. So, but it's Kubernetes at the end. So I hope it's okay. Okay, let's check what is going on here. And now it's running. So what we should see now sometime. Oh yeah, okay, we go back. You trusted me that I shared. Yeah, and what we can see now that client address is not authorized. So our application cannot get the secret anymore. At the pod, so what's the outcome? Our pod will die. And this is some behavior what we do not want. So now we have to improve our pod that it will not die when the connection is there. Maybe we will implement something like caching, or we will implement something like a backup scenario for secrets. I don't know. So yeah, but this is like how I mentioned is in Kubernetes. So there's also a common scenario that the secrets are not available by whatsoever, and then the application just dies, and this basically we do not want. Okay, this was the one scenario. I'll make it clear. And what we do then more is we do the chaos on the AKS. Now we will use chaos mesh, and chaos mesh. We will look at the code also now. What we do here, we create the experiment. We will assign the chaos experiment identity. Also, we did it on the AKV. We will assign it to the Azure Kubernetes Service Cluster admin role, which was recommended by Microsoft. I also did the same here for the key vault. It was key vault secret user. This was the identity of the chaos experiment for the Azure key vault. So basically, we just have these two commands. And what we do here is basically, because it's a module, we will get the existing cluster here. We will create the target on this cluster, and we create the experiment. And what we do here, we will inject the action, which is pod failure. Mode is all. We have to check this. What is this? Chaos mesh mode all. In the meantime, duration is 5 minutes, and the selector, we will say namespace is Fred, because Fred is our white duck mascot, and we will use the Fred demo for this. And I have to check what is mode all. I'm not prepared for this question. Chaos mesh mode all. Maybe Nico can help me and look it up.
Yeah, kind of.
Yeah, and then we just output the ID of because this experiment will create the system manager identity, as you can see here. And this we will output and we will use for the role assignment. Basically, that's how we will do it here. And okay. So we have can you get pod. Sorry. Go to the free namespace. Okay. Okay. Oops, sorry. So my pod seems not to be running. That's interesting. Why is my pod not running? We get pod -a. Now we can fix this. Or did I use another namespace? Disconnection. No. Okay. Now I can do. Let's try just this here. Does not come up. 1 second, please. Looks good. Okay, no worries. I will get that. Okay, now it should be. Something that seems with the running. Okay, I know what this test connection is, but okay. Okay, 1 second, I just verify this is running. Okay. So basically, I will do it here for screen. Basically, this is our demo app here. So we have the Freight application. So it's running now. I just do the QCD port forward on this port 8080. What we do now is we will just inject. Let's see if there's any outcome here. Yeah, the success. So when we start the project or the experiment, we will also, first we have to look if I enable the capabilities, because this always happens to me that I miss the enable the capabilities, and then I'm wondering why my experiment is failing. Okay, this looks good, and then we can just run this experiment here. Okay. In the meantime, I'll create a new mesh. Okay, and control demo. Now when the experiment is finished, so the Azure keyword enabled the public access again. So we will able to fetch our secret. So that is good. So okay, good. So we will change to the free namespace. Put. I don't see it. Oh, I'm sorry. Okay, here we see it. Okay, so the application killed our put. And now it started again because Kubernetes will restart it. Yeah. Or also not. Maybe it's injecting again for it. Let's see. I'm just gonna switch back to the, let's see what's going on here. You can see our branch and our action, our step. As we run the pod chaos, and we can see that it's running on this key vault. Sorry, Kubernetes cluster. So again, it will just kills the pod randomly, so it does not will come up. Okay, and what we maybe could do now when the project is finished to where we resolved it, we can maybe try to, let's try run 2 pods of this, because then our session will be killed for sure if we are on the pod, which will be killed, but the application will still work hopefully. We have to wait a little bit till the. I'll just share my whole screen. Maybe it's a bit better here. One second. This one. Okay, maybe it's a bit better here. I can see it a bit better. So our project is still running. And we have here 5 restarts. It could be also where the pod is broken. Oh, I hope not. Cache loopback off. Okay, logs. We need another pod for demo. It will be no logs. Okay, then we do just k run. Demo. I got to forget my run demo, which namespace we are. Okay, and it. Okay, run box match. Let me just check it in Nginx because I don't know if the application is stable. Run demo. Pods. Creating. Okay, this is running. Does it still inject faults here? Then we delete the others. Okay, delete pod. The application. The deployment. Okay, let's see what's going on now. Okay. So basically, when we just don't have any pods, so what we basically can do now. So see if it will restart the pod. No. I will just scale the, okay, scale. Oh, I cannot scale it because it's a pod, right? That's tricky. Okay, I will search for a sample deployment. I think the Selenium GitHub. The guys from Selenium, they have a good demo. When I will find it, Selenium examples. Policies. Oh yeah. Okay. Okay, delete. Is it also deployment here? Sorry that my demo is not working. Okay, this is not. Okay. So now we are better here, I think. Okay, we can also okay, scale deployment. Dev star, down replicas, let's say 2. Yeah, but it's not a web application, so I don't know. Okay, logs. Okay. Dev star. Maybe it's a web application. port forward service. So, 80. Always mix that. But the service has no port 88. Good. Port forward service is not a port 88. Okay, I'm gonna go to localhost 8080 now. Okay, we at least get something. Okay, so this was, so we just run it again. Then we scale the replica. Okay, let's see how it's reacting here. So we are connecting to this one pod and see. So something happened here. So it's killing some. So maybe the mode all means it kills all pods or something. Okay. So basically, our application would be also not that stable in this case because all pods are killed. So maybe we have to do another scenario where we only kill one of the pods. Just figure it out. Okay, I think as my demo not worked, we can skip that here. I also wanted to try another because I found it that the chaos experiment, where is it? Default library, yes. It also has a DNS issue and a DNS fault, and I wanted to test this one. So basically what we do now is just we clone this one here. We just rename it to, okay, this will not work, to DNS. Okay, so we will put the cluster. We create the target. Okay, we create the target DNS. Cluster. Okay, then we will call it DNS chaos. We will call it DNS, and then in the namespace we use the AKV demo because this one uses the name of the URL of the keyword. Basically, what we do is we have a selector. So our list is selector 1, and this is our target, Chaos Studio target ID. So we named it now to. And this, by the way, is always Chaos target, so it does not matter what you use. And then we use Mr. Backticks here. By the way, okay, put this here. Then we will enter the DNS chaos. And what you have to do also, you have to enable this DNS chaos on the chaos mesh. So there's an installer command, and then you have to go pods -n chaos testing. Also, Microsoft or the Chaos Studio expects that Chaos Mesh is installed in this specific namespace, so you have no change to rename it. So it has to be Chaos testing. Then you have this Chaos DNS server. Here's the dashboard and the control manager and the daemon, which I showed before. What we do is continuous. We have continuous JSON spec, and then basically we just copied it. And then we'll remove all Let's wait. We'll just do it. Just do it side by side, because bicep and something expects different. Okay, afraid, so we will use our namespace AKV demo. Namespaces, and this we remove, selector is okay. So I think we can also skip this until here. Patterns. I could also use better functions to remove it, but I'm old school. Okay. So this has to be also gone here. Okay, action, random. This random mode looks good, or patterns on, and then we just have to say, oops. Namespaces, okay. Okay, let's see. This will work. And then we have to just say which DNS, and then we have it here on the demo. Before demo put, I will just do something like Vault Azure Net. What they did here, chaos mesh, github.com, or we'll just use the whole. I don't know. I just use this here. No, oops, sorry. Here. We will use this here. Okay. So basically, it should now. What we have to do now is we have to assign the experiment identity again, the Azure Kubernetes administrator role. So let's see, maybe this will also not work because it's already used. Let's see what it will say, and we go to the main. We copy just this here. We call it chaos DNS, chaos DNS, chaos experiment, AKS DNS. Oh my god. AKS chaos DNS, for example. Okay, AKS cluster. Okay. Pod DNS chaos. Role assignment. Here we just choose DNS chaos. We will keep the role here, and we will use this one here. Okay, that should be it, if I'm not mistaken. Okay, then in the README you will find the commands how to deploy. Let's see. I don't run the what if now. I just try to run it now. Main bicep podcast. Main bicep. Guys, where is podcast? Here. Podcast. Okay. This does not exist. DNS chaos principal ID. Then we have to rename the output for sure to this one here. Okay. And then basically it should work, hopefully. In the meantime, we can check as I enabled all the capabilities on the AKS. And what I mentioned before, you also see not all the resources here. So we only see which are enabled. And then we have the manage actions again. So we have to enable the DNS chaos here. And then let's see how what will happen when we run the experiment. I think then we're also done for today. Are there any questions until now? I think not, because of the good demo.
No, no questions on YouTube.
Hmm.
And I guess also on Zoom here. But still, if you have questions, feel free to post them.
Not fail, no. Okay, in the meantime, I think until we wait, we can go. Oops. We can talk about this one here, right? So, Nico, you want or I?
Doesn't matter. Feel free to. Okay. So just as a follow-up, we have some next events planned. End of May, we're doing another Azure Rosenheim meetup together with Pulumi. So Engin will join us for them. Yeah, Pulumi fun on Azure, which shows how it works, give us perspectives and stuff like this. So if you'd like to join, feel free to once again go over to our Azure Rosenheim meetup page and register for that one. And last but not least, we have another event upcoming in June. So maybe perfect. Thanks, Phil. So we'll do at 29th of June a Cilium and AKS workshop day together with Azure and Microsoft at the Microsoft headquarters office in Munich. Basically, will be a full day of Cilium and AKS. So we will show you all the stuff around ePPF, around Cilium, how you work together with tools, how you integrate them with AKS, all the benefits, and talk about networking, observability, and also security, that stack of stuff with the Tetragon tooling. So if you'd like to learn more on Cilium, ePPF, and how to integrate it with AKS, also feel free to join us here. As I said, it will be on site at Microsoft Munich end of June. Okay, and Bicep is still running.
Bicep is still running, yeah. But let's see. It's also not here. Let's see. Let's see if I did something wrong. I think not. But this is a new target. This is the target, is okay. The main, you have the AKS, but no, looks good. Maybe it takes some time because of the role assignment on. Oh, no, it's there, you see. Okay, let's see. Well, the naming is not bad. The naming is bad. Can also take a look in the meantime. You have this. Yeah. I just did the role assignment is now on resource group level. I mean, it should not be the common scenario, so you should set it really on the resource. But for me, it was easier now. Yeah. But here you can see that there's some old identities maybe from before, and the new is not there at the moment. Doch, there's the new one. Oh yeah, there are two identities, and the other one is directly on the keyboard, or on the keyboard resource group. Okay, Bicep, come on. Yeah, but now it's a good time for questions, I think.
I asked again just some seconds ago on YouTube if anyone has questions, but no questions so far.
Okay. Then I just talk a little bit more until Bicep is finished. Yeah, so if you want to play around with this Azure Chaos, so as I mentioned, all the code is on GitHub. So the Bicep stuff is also working, also with the federated identity credential. what is not working, this could be here. Maybe I inserted the code here. No, but we can take a look at the issue here. So this is the issue why you cannot add the capability via Bicep, and this is fixed in 0.17. And until this, we have to do it manually, and then hopefully we can add the capability also with Bicep or with Terraform as the AZ provider. Then we'll update also the repo and see what's going on and test it. Oh, it really takes long. Yeah, but I want to see the DNS fault, so we have to wait. Ah, no, it's finished. Perfect. So basically, what we can do now, we also did create the right namespace, or RKV demo. Okay, and then let's just run it and see what's happened. And then happened echt. Yeah, today is not my day with my keyboard. Okay. Let's wait until it's running. Waiting to start. Yeah. Let's see if the another pod is starting. Okay, good. Okay, and let's see if here's something happening. Let's see if this pod is putting something out. No, it's running. Ah, here. So receive send chaos request. Okay, and so this sends now this pattern to, but maybe we shouldn't had not choose random because random. Let's see. Okay, and RKV demo. Okay, logs RKV. Maybe we don't see anything because we choose random. Let's see. Documentation. So I have to say the documentation is somehow could be better, I think. Random. Application. Do you find something for mode all? Nico?
Not really, to be honest. I also checked the documentation. It describes all the parameters, but nothing about mod all.
But from the Azure documentation.
So how long is the experiment running because of random?
5 minutes.
Yeah, so
yeah,
maybe within the 5 minutes we are getting something small.
The bot is only asking 5 minutes. So
yeah,
we should maybe run our own pod and just run a curl on this. I think. Okay, run. Okay, let's try with net shoot.
by the way, thanks, Christian, for the check on the chaos mesh docs. So mode all means basically all eligible pods.
Okay. Achso, das muss ja wieder hier, braucht ihr so ein Command, oder? Macht er dann curl nur einmal oder was? Machen wir einen Ping, wa? den ergeben. Where is my URL? Oh nein. Image can't be pulled. Ah, der kann kein DNS-Lookup oder, ne? Hm. Okay. This guy pod. Okay. Maybe we just allowed this one Azure keyword and disabled everything else. We have to check the docs. Patterns. Maybe this is allowed thingies. This we have to check now. Where is it on the? Do you find this section here?
So check the meeting chat from Zoom. Christian posted
Yeah, it's
some.
hard here. Wait. Shit. Ah, Christian, alles gefunden. Thank you, Christian. Hmm. Action, random. Ah, so random returns a random IP address. See? And the value is DNS, so returns an error. It matches false. Specify experiment, but wait, cannot pull the Docker image. Questions after questions here. Ah, so the Zoom window here. Okay, delete. What? Fold. Sorry, curl. Again. Okay, run. Image net shoot. Error image pull. Okay. Okay, run image. So engine X minus. Ja, okay. Okay, Netshoot gibt es nicht mehr, aber ist okay. Ist ja wieder super. That is running good. Okay. So, but the pattern should match. Select a domain template that matches forwards. Placeholder and wildcard are supported. But then it should not. But random means random IP, so there should not be DNS, right? That's what I understand. Mode. But we have mode all. All pods, okay. Value. Okay. But from my understanding, if we enter the domain here and then run the experiment, there should not be DNS, correct?
It looks like, yeah.
Okay. Interesting. Okay, let's wrap up this session because we're long. We will figure this out and release. Nico will release a blog post.
Okay, so do we have any further questions? Then it's the last time now to ask them now. You can also find us on social media afterwards, but if you have any questions, feel free to post them. And otherwise, I think we're wrapping up today's meetup. So as we said, feel free to join us at the next one, Polimi one with Azure, with Engin, or even on-site one we're doing together with Microsoft and Azure. Yeah. Phil, do you have any last words? Useful links?
Yes, something about chaos engineering, Netflix, Siemens Army, here Martin Fowler, Phoenix Server, Microsoft Learn, Azure Chaos Studio, and the code from today's session. I will also push the DNS stuff and then we can test it further. I mean, it was an experiment and it did not work as expected. Okay.
Okay, so then I would say
chaos engineering.
So it was just the Chaos Meetup experiment you run, huh?
Yeah.
Okay, perfect. So then let's sum up. Hope everyone had a great time so far, and yeah, I think we will see us in our next meetup. Bye bye, everyone.
Bye.
Bye. Thank you, Phil. Thank you, Nico.